Hi guys, hi everyone. Welcome back to my channel. Today we are learning about the how the CPU executes the instructions in your computer. In our previous video, we have had a brief explanation about the threads and also the process, how the processes runs in our computer, and what are the different process states and all those things we have discussed it, right? So let's try to learn about the this one. So how the CPU executes the instructions in your computer. So normally, if you have ever seen how your code turns into an actions and why your program gets stuck, sometimes when you try to execute a program or something like that, your program gets stuck because of infinite loop or something like that. So why it will be stuck, something like that. So let's try to understand about this one in this video. So now, first of all, before learning about this one, so you need to understand what are instructions. Okay, so what is an instructions? So everything, whatever the CPU, so CPU here executes only the instructions. So what only executes is the instructions that has given to it. So whenever you write code like in Java, whatever it may be, it can be a JavaScript, C program, or Python. So anything, any program or anything, whatever the thing you are trying to write it. So this code will be converted into a tiny commands. So whatever the things you are trying to read, it will be converted into a tiny commands. These are called as an instructions. Okay, so these are called as an instructions, and instructions will be in such a way that each instructions will be something like what I can say is it is a single step. So it's a something like a steps to follow by the CPU. So steps to follow by the CPU. So this is the how you will be having, and these all instructions will be stored in the in the memory. Memory means it's you can say computer's memory. So now think of it is like a example, like a recipe or anything. So each line is a step by step, and every step has a memory address like a page number in a cookbook. So let's say that if you are having example where x is equal to 1, something like that, and this line will be converted into a series of instructions. And how it will be having is, so for let's say that you will be having a memory location, something like that, and the instructions will be converted into some binary digit number. Okay, so don't think that 2 I have written, so it will be all 0 1 0 1 and like that. So now in this memory location you will have instructions, and these instructions will get executed. Okay, and you will be having another instruction, something like 2 3 5, so like this. And in this memory address, so you will be having another instructions which is all a binary digit. So this is how you will be having, and each instructions it will be executed. So this line will be converted into something like this. So this is how you will be having it. So this is how you will be having the execution for this one. So like this the instructions will be provided. So using those instructions we will be running this one. So that is the thing. So now how the instructions will be executed. So now let's try to see. So for this one, so how the instructions will be executed in the CPU, if you want to understand it, we need to understand about the program counter. Okay, so it should be something like program counter. Program counter, we need to understand it as a program. What is meant by program counter? In short form we call it as in PC. So this is what the PC we did. So now what is this program counter? So this is the where the magic actually really happens here. The CPU uses something called as a program counter. So what is this program counter? It is something like an reference. So the pointer. So here the pointer it will try to do. So the pointer will be here like this. The pointer will be. So whenever you are trying to execute the instructions, first the pointer will stays here. And when this instruction is executed, the pointer will shift to the second line. So like this, the pointer will be there, which will be executing. So here the PC is something like a finger or anything pointing to the exact instruction the CPU should execute the next. It is always pointing to one instruction at a time. So always the pointer will be pointing to only one instruction. Why? Because you'll be having a single pointer. So that means you are having a one CPU core. If you are having a core executing a instruction or a process, means it will be having only a single counter. So what is a program counter? One core will have only a one program counter, and it moves forward and something like that according to the instructions that has been provided to it, and it moves forward as the CPU works through your code. So let's try to understand how CPU executes the instruction. So how does this work? The CPU looks at the program counter to find the memory address of the next instruction. So here it will try to see the program counter is here, and it will take the memory address and it will try to go to that memory address. So what is that instruction you are having? And it fetches that instruction from that memory address and brings it into the CPU and executes this one. So in this memory address, you will be having this instruction and it will bring it to the CPU and it will execute it. And then the PC will move it to the another one. So if you try to see it, sorry, let's try to copy this one. And here I will paste it. And now when this instruction has been executed, the program counter will move to the next instruction and the cycle repeats same thing. So again, it will try to fetch the instructions from this memory address and it will try to get fetch that instructions from the memory address and it will say add it in the CPU and it will execute it. Okay, and brings it into the CPU and it will execute it. So this is how the CPU executes the programming code. The fetch, execute, move, over and over, it will try to do it. So it is not always a straight line. So you will be having a series of instructions. Okay, so let's try to say you are having a series of control. How it will be. Alt. Try to fine. Okay, fine. So let's try to good. So now if it is the instructions executions, it will not always be a straight line. For example, let's say that you are having this type of executions. So let's say that you are having this type of, so you are having a series of instructions, let's assume. So you are having a series of executions, something like this. Oh, so these are all different instructions, assume it. And the program counter is in such a way that it is at here. So it will fetch the executions and it will execute it and it will move to the next one. Okay, so it will move to the next one. So it will not always go it in a straight line. So what will happen is, for example, let's say that in your instructions you have a for loop, let's assume, or otherwise it's an if statement or a function call. Now the program counter, what it will try to do, it will jump into the different instructions. So let's say that here it got a for loop, so that it needs to repeat it from the second line. So what it will try to do, again the program counter moves to the top line and it will execute it here until this line with the program counter will go on executing until the for loop is finished. So like this you will be having. So a loop might send the program counter back to a repeated code of block, or a function call might jump into another part of the program. So the PC keeps track of where to go next. So here the program counter keeps track of this one. So now the key point you need to understand is, if you are using a single core CPU, so if you are having a single core CPU, you can only have one program counter. This is what I want to explain you. You can only have one program counter. That means the CPU can only execute one instruction at a time per process. If your code gets stuck, means like in an infinite loop, the PC keeps on circling in that loop and other instructions like console.log, whatever the lines are there in the bottom, you might never get a chance to execute it. So that is what you need to understand. So we are having a single core, only one program counter will be present. So every program runs as a process. So you know that one, every program runs as a process and each process has its own program counter, and process can be of any different state. One is running state, the CPU is actively executing the instructions, and ready state, it is waiting for the CPU but ready to go. And sleep, it is paused, waiting for something like a user input or a timer. When a process switches states, like from running to sleep, the operating system saves the PC position. So for example, let's say that this one has been moved from running state to the sleep state, means the program counter will be saved. So here you need to understand the PC position. So here whenever the process moves from running state, so let's say that the program counter is in the second line, second instruction. Now the process has been moved to the sleep state. So the CPU will remember this program counter where it is there. When it comes back to the running state, exactly the instructions will be executed from there. So this is, when it comes back to running, the CPU knows exactly where to resume the executing or where to pick it up. That is the one thing you need to understand. The next thing what I want to explain you is the context switching. So now you need to understand something cool, that is nothing but your CPU doesn't switch to one process. Okay, I already told you. So we have a something called as a CPU scheduler. So we'll be having something called as a CPU scheduler. So what is the CPU scheduler? So let's say that do we have a paint in the, I think that we have a paint in this one. Paint, don't have a paint in this one. Let's try to search it in the online. Try to search it. Go to here, online paint. Okay, let's take this JS paint. Yeah, so let's try to understand the basic thing. So here uh, let's say that here you are having like this, okay, and here you are having the CPU, okay, this is the core, and here you will be having the processes. You have a little bit only. Yeah, so this is all the process. So here you will be having one process, and here you will be having a second process. So this one you will be having the third process, let's assume. So this is all in the ready state. Okay, ready state. So these are all ready to be executed. These all processes are ready to be executed, and this is the core you are having, which a CPU core. So this is a single core which you will be having. So now what we need to do here in this one, so this is a single core which we are having it, and now you will be having a dispatcher here. So here you will be having a dispatcher. So dispatch will move the process from ready state to the running state. Here this is the running state, and at the bottom you will be having the sleep state. So this is called as a sleep state, and each process will be in the sleep state. So something like file uploading or network waiting or anything, so keyboard input or mouse input waiting process will be there here. So when you will be having a event will be risen, and it will go into the, whenever event OS raises the event that your request has been came, so then the process will be shifted from to ready state. So like this the things will be happening. So here what will be happening here, the process, so first you will be having this process, and this process goes to here, and you will be having a CPU scheduler. I already told you, right? The CPU scheduler will be there. When the process goes into here, let's say it will be executing 100 milliseconds. Okay, 100 milliseconds it will execute, and thereafter again it will go into the ready state. Why? Because remaining processes are there in the ready state which needs to be executed. Again the process 2 comes to here, and this one goes here, and again 100 milliseconds it will execute, and again it will go into the ready state. So like this you will be having place. So this P3 will come. So like this it will be going on execute 100 millisecond until the process is terminated or it is done. So then it will go into here, or otherwise if it has anything means it will go into the sleep state. So it wants any something, it waiting for any network request or anything, it will go here. So this is called as an context switching. So switching from one state to another state is nothing but a context switching. So here that means your CPU is not sticking to only one process until the one process is until the process is completed. It is not sticking to the one process. So it is going on executing the process one by one, whatever the things in the ready state. So it is switching the process. So immediately with a fraction of seconds, it will be switching the process, so that you will be getting an illusion in such a way that all the processes are executing, and the single core is executing simultaneously. But here the core is not executing multiple, it is executing all the cores by switching the context. So here it switches between them super fast. This is called as then context switching. For example, if you are running a Node.js program with a loop, the CPU might pause it, save the PC, and switch to another process. For example, you are having a Node.js loop or a Node.js or something like code, and you are using a while loop or something like that. It is an infinite loop. It will go on execute this one, and it will move to the sleep ready state again, and it will execute the another process. So it will be going on switching this one all. This happens so fast that it looks like everything is running at once, but it is not. It is really just one instruction at the time per core. That is the main thing. So we will be having a simple example or something like that. So we'll try to see about this example so that you can have a clear understanding about this. So this is all the basic thing, how the context switching and all those things will be happening. So hope you understood about this concept. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you.